Okay, today is the 8th of February and we have our third 70 plus degree temperature day, and I'm still getting comments about, are we going to get any snow? Yes, we are going to get snow tomorrow morning. Timing on this one is perfect. But the other two things in terms of air temperature and more importantly ground temperature is not good. But this is not a snow video. This is going to talk about an eclipse that we're going to be getting on the 10th. So let's see, today's Wednesday, that'll be Friday. Friday, as the sun actually goes down and as the moon rises, it'll be eclipsed. And I'll show you the maps about it. But the first thing I want to do is I want to show you about shadows. Anytime you actually cause a shadow, you have two parts. You've got a darker part, which is called the umbra, and if you look around on the outside here, you have a lighter part that's called the penumbra, and the penumbra gets brighter as you move out, and it gets darker as you move in, and then eventually hits this nice dark line, which is the beginning of the umbra. But you got some other things going on here because this thing is actually sitting on the paper, and it's not an astronomical thing with, hundreds of thousands of miles in between. Okay, so this is what's called a ray diagram, and this is a diagram showing you a lunar eclipse, and it's not to scale. These two objects are 93 million miles away on average, and these guys are 250,000 miles away. Basically what happens is we have the sun, which is 400 times larger than the moon, and we have the moon 400 times smaller, but it's also a lot closer, 400 times closer. So we have these perfectly set up astronomical bodies, so we actually have the sun and the moon being about the same size, assuming that we're not at perihelion and aphelion at the same time, but we get it about the same size. And the nice thing about this one is the Earth has a much larger shadow than the moon, where we get a very small solar eclipse shadow, which may only be 30 miles across as it races across the surface of the Earth. So very few people get to see this. Somewhere around 60 to 70% of the entire planet gets to see the difference between a penumbral the umbral and the penumbral eclipse. But this one is going to be what's called a penumbral eclipse. So it's not going to be a total eclipse. It's not going to be a partial eclipse. It's going to be a penumbral eclipse. So let me show you what I mean by that. So here's the sun and here's the Earth. And if the moon actually just passes in the umbra part of the shadow, the lighter part of the shadow, it's called a penumbral eclipse. If it actually moves through part umbra and part penumbra, it's called a partial lunar eclipse. And then if it moves into the umbra, and then it's called a total solar or lunar eclipse. And if you take a look at this picture, this is a penumbral eclipse, and you can see there's the umbra part of the Earth's shadow, and we have the moon moving across, and this was in 2006 in March. We have the moon actually moving across the sky. Usually it's too high or too low or too far on this side or too far on this side, and we don't get an eclipse, but every once in a while the moon moves through the Earth's shadow. And as you actually watch it move through, it touches, goes into the penumbra, doesn't really touch the umbra, and moves out. If it moves through the penumbra and touches the umbra, then this is called a partial eclipse. And if it actually moves through the penumbra and then into the umbra, it doesn't have to be right smack in the center of this one. It can be over here. Just as long as the entire moon is in the umbra, we get it. So here's the February 10th lunar eclipse. I'm going to actually enlarge this one because I'm going to show you what's happening. Is here's the moon, here's the Earth's penumbra, there's the Earth's umbra, and I'm just going to click and you can watch this as it goes through time. Come on. As it goes through time, the Earth, actually the moon is moving. The Earth is moving as well, but the Earth's shadow moves like this, and you can see the magnitude of the moon. It's getting darker. It has a darker section. If I move up here, it's got a much darker section up here because it's closer to the umbra. But then as it moves around and through, you can see it misses the umbra, not by much. It almost all gets into the penumbra, and that is a penumbral eclipse. Who's going to see it? Everything in this pink area is going to see it. We're located right here, and as you look down here, the penumbral eclipse is going to begin. It's February 10th. It's 2200, except this is UTC. We're in DC, and we're about 5 hours later than that. So it's actually going to happen at 5:34 p.m. It'll actually, as the moon rises, it'll actually enter the penumbra. Maximum eclipse is going to be at 7:43. Friday night, and then the penumbral eclipse will end at almost 10 o'clock Friday night. Okay, so that's the way it's going to work, and it is going to be on, for us, it'll be the 10th. If you notice over here, it's going to actually be the 11th. But it gets later and later as we go this direction. You cross the international date line, it becomes tomorrow. So it's the 11th over here and the 10th over here. But for us, it'll actually start happening, like I said, right around 5:30 Friday night, and it'll be over right around 10 maximum. And you'll actually get to notice, if you take a look at this section right here, you'll notice that the top of the moon is going to be the darkest part, and you'll be able to see this as long as the sky is clear. Hopefully the snow will be out and it will have a nice beautiful clear sky to see this. Okay, that's it. Eclipse Friday night. Be there.